Okay, so solving radical equations is what this is called. So these are going to be equations that obviously have a radical in them. We've solved equations before that had exponents where we had to use a radical to solve, right? We would have to like take the square root of both sides or take the cube root of both sides or the whatevereth root to both sides. But we've not done problems yet that have had a radical sign in the original problem. Okay? So we might have a problem that looks like this. Cube root of x minus 4 is equal to 0. And the steps are going to be fairly similar each time. You want to first isolate the radical sign. Get the part that's the radical by itself. So, what needs to happen first? Add 4. Okay. Cube root of x is equal to 4. And so, like we do with all types of solving, we want to use inverse operation. What would be the inverse of a cube root? What's the inverse of all roots? I'm hearing a little bit of mumbling, but I'm not sure what you're saying. Raising it to the third power, I think is what you're saying, right? Yeah. So powers and roots are inverses of each other. Make sense? That's why when you had a power problem before, you took a root to solve it. So now that you have a root, you're going to raise it to a power. And you need to make sure your power matches your index. So if it's the third root, if the index is 3, you want to raise it to the third power, and that undoes your radical, and you're left with just x. And then hopefully you do not need a calculator for 4 to the third power, but if you do, go ahead and use it. And you have your answer. Make sense? So unlike when you were taking roots of both sides, you don't have to keep track of, okay, well, was it an even or an odd root? Do I have one solution or two solutions? You don't have that. When you're raising to powers, you with me on this? When you're raising to powers, you only have one answer. Make sense? It's when you're taking roots that you have multiple answers whenever it's an even root, one answer when it's odd. Let's try another one. We're going to do the fourth root of x plus 1 minus 2 is equal to 0. Go ahead and work ahead a little bit. Let's see if I can catch up. Are we good? X equals 15. Okay, is it a good idea to check your work? That should be the same answer no matter what the scenario is in math, right? If a math teacher ever says it's a good idea to check your work, you should say, yes, of course, it's a great idea to check work. So 15 plus 1 is 16. The fourth root of 16 is 2, right? 2 minus 2 is 0, so we know it is a good solution. Always a great idea to check your work. All right, another example. These can be presented in a lot of different ways. So how about if it looks like this? What does x to the half power mean? That just means square root, right? So just because it's presented as a fractional exponent doesn't change the fact that we're still having the square root of x, right? So because it's still the same type of problem, it's still the square root of x, we're still going to be raising it to what power? The second power. Now, we don't have to rewrite it as the square root of x. Like, we don't have to go through that step. We're just going to do this. So we call that raising it to the reciprocal power. The reciprocal of 1/2 is what? 2 over 1. Now, do you have to write 2 over 1, or can we just write 2? Just write 2. That's fine. Because remember, our exponent rule says that if you raise a power to a power, you multiply them, right? And 1/2 times 2 is just 1, and that's our whole goal, is to get what x is equal to, x to the first power. And what is 5 squared? 25. That one was easy. Of course, they're not always that easy. We're just starting off easy. So when you see an exponent that is a fraction, you don't have to change it into a radical sign. You can just raise it to a power that is its reciprocal power and go from there. So let's try this one. 2x to the 3/2 power is equal to 250. What has to happen first? Must divide by 2. You got it. Because we have to isolate the part that is being raised to the power. We get x to the 3/2 power is equal to 125. All right. What would I raise each side to? What power? Yeah, to the reciprocal power, right? So 3/2, the reciprocal of 3/2 is 2/3. So I'm raising this 125 to the 2/3 power. This brings us back to a lesson we've done earlier in the chapter. You do also have a calculator, which will take you longer to do. But you're welcome to use a calculator here. We know that if we raise 3/2, x to the 3/2 to the 2/3 power, we better get x. That was the whole reason we chose that power. So I don't really have to do anything on the left side except write x. I know that 3/2 times 2/3 is 1, so that side is just x. Now listen. The bottom number, the 3, is your root. You guys all know what the cube root of 125 is, right? What is that? 5. Now raise that to the second power. Come on, guys. 5 to the second power. 25. There's your answer. You don't need a calculator to do that. Have some confidence in what you're doing. Now, if you are going to use a calculator, raising a number to a fractional exponent in your calculator is going to require some parentheses. So when you raise 125, you hit the raise the power button, start with a parenthesis, and then do 2 divided by 3, close your parenthesis. I don't know if you can hit the fraction button when it's in the exponent position or not. Can you? You can, okay. I grew up with calculators without fraction buttons, so I had to use the divide sign, which is amazing, right? Somewhere we lost the fact that divide means fraction, and fraction means divide. So not too bad. We're just doing the whole idea of inverse operations. That's really all this is, more solving, right? You all right with that? Okay, let's try another. Square root 4x minus 7 plus 2 is equal to 5. How'd you do? Did you get 4? Yeah? Okay. All right, so those were the baby ones. Those are the easy schmeezy ones. Let's kick it up a notch, right? Let's kick it up a notch. Okay, square root 3x plus 2 minus 2 root x equals 0. How is this one different? There's 2 square roots. Yeah. But steps are still going to be the same. You're still going to isolate one of those 2 roots. Okay, I would recommend we isolate square root of 3x plus 2. Okay, so let's isolate that one by adding 2 root x on both sides. And then, of course, we're focused on the left side now. We're going to square both sides.
So this is one, or is it 2 separate?
Well, it's one term, but both parts get squared. So the whole side gets squared. So
they both moved over.
So it ends up being 4x. Yeah. So this side is just 3x plus 2. But that's why I'm saying use parentheses. Like, really show that you're squaring both sides. Don't just put a little 2 out there. Remember, you're squaring the whole right side. So the 2 gets squared, and the square root of x gets squared. So the biggest mistake here that happens is people write on the right side, they just write 2x. But it's really a 4x. Well, now the math is easy. We get to solve it like a freshman. Subtract 3x from both sides, and we find out that x is 2. Now, do you think it's a good idea to check your work? Always a good idea to check your work, especially as we get into these ones where there's multiple x's, there's multiple roots. Always check your work. All right, so let's do that. Let's actually formally do that. Let's plug the value back in, not just in our head, but let's write it out. Let's do the check. 3 times 2 plus 2. We want to know if that's the same thing as 2 root 2. That's what we're checking, right? Thank you. All right, so 3 times 2 is 6, plus 2 is 8. So is square root of 8 the same thing as 2 root 2? Well, let's break it down and see, right? Square root of 8, that's 2 times 4. That's 2 times 2. It's a square root, so that means the index is 2. So we look for pairs. We have a 2 that comes out and a 2 that has to stay. So sure enough, that means the same exact thing. I know that that is a good answer. I come up to my answer and I circle it now that I've checked it. All right. Let's try another one. X minus 4 is equal to square root of 2x. Please do not break this math teacher's heart when you square both sides. I'm begging you. The square root's already isolated, right? So we're ready to go. I'll do the right side, you guys do the left side. Okay, I did my half. Now you do your half. And we split jobs equally around here, right? Sign right here. Oh, you broke my heart. You're killing me, Smalls. You're killing me. I said, you're killing me, Smalls. Oh. It's a movie quote from I don't know where. Huh? The Sandlot? That might have been a quote even from another movie. X squared minus 8x plus 16. Please, for all that is holy in the land, learn how to square a binomial. I cannot send you on to the next level of mathematics without knowing how to square a binomial. I'm telling you, that the trig pre-calc teachers will, they'll hang me. They really will. They'll like, who are you sending?